5-foot rule for grounding the service panel applies to copper water piping, as well as all other grounding electrodes used in the electrical system. This rule states that the grounding electrode or electrodes must not be more than 5 feet away from the service equipment, that is, the service panel. A service panel can be grounded to a copper water line, but there are a few important considerations. The distance between the main entrance of the water line and the service panel is not critical as long as the grounding electrode is within 5 feet of the service panel. The copper water line must be of sufficient size to provide a low impedance path to the ground. At least a 1/2 inch diameter copper water line is recommended. The connection between the grounding electrode and the copper water line must be secure and permanent. Use a bonding clamp or approved grounding lug and follow the manufacturer's instructions for proper installation. If there is a metal water meter between the main entrance of a water line and the grounding electrode, the meter must be bonded to both the grounding electrode and the water line to ensure a continuous path to ground. If the copper water line is not accessible or does not meet the necessary criteria, other grounding electrodes can be used, such as ground rods or UFO ground. It is always recommended to consult with a qualified electrician to ensure proper grounding and adherence to all applicable electrical codes and standards. Grounding is a critical aspect of electrical safety, and understanding the requirements for grounding electrodes, including copper water pipes, is essential for ensuring a safe and reliable electrical system. The purpose of grounding is to provide a low impedance path for fault current to return to the source, which allows overcurrent protection devices such as circuit breakers or fuses to quickly trip and de-energize the circuit, preventing electrical shock and fire hazards. The National Electrical Code, or NEC, provides detailed guidelines for grounding electrical systems. Section 250 covers grounding and bonding requirements. Within this section, specific rules address the use of water pipes as grounding electrodes. The 5-foot rule is a common reference, but it's crucial to understand the complete context. The NEC requires that a metal underground water pipe be used as a grounding electrode. This water pipe must be in direct contact with the earth for at least 10 feet. This requirement ensures that the water pipe provides a reliable connection to the earth, allowing it to effectively serve as a grounding electrode. The 5-foot rule comes into play when considering the connection point of the grounding electrode conductor, or GEC, to the water pipe. The NEC states that the GEC must be connected to a water pipe within 5 feet of its point of entrance to the building. This requirement minimizes the impedance of the grounding path and ensures that fault current can quickly and easily flow to ground. Even if the main entrance of the water line is more than 5 feet away from the service panel, the connection to the water pipe must still be made within that 5-foot distance from where the pipe enters the building. From that point, a bonding jumper is typically run back to the service panel to ensure that the panel is properly grounded. In addition to the water pipe electrode, the NEC requires that a supplemental grounding electrode be used. This supplemental electrode can be a ground rod, ground plate, or other approved type of electrode. The purpose of the supplemental electrode is to provide an additional grounding path in case the water pipe electrode becomes compromised or ineffective. The size of the grounding electrode conductor, or GEC, is determined by the size of the service entrance conductors. NEC Table 250.66 provides guidance on selecting the appropriate GEC size based on the size of the service entrance conductors. It's important to consult this table to ensure that the GEC is properly sized to handle the expected fault current. The connection of the GEC to the water pipe must be made using an approved fitting, such as a grounding clamp or lug. The fitting must be securely attached to the water pipe to ensure a reliable electrical connection. The fitting must also be listed for grounding purposes. When connecting the GEC to a copper water pipe, it's important to avoid using dissimilar metals that could cause corrosion. For example, avoid using aluminum connectors on copper pipes, as this can lead to galvanic corrosion. Instead, use connectors made of copper or copper alloys that are compatible with the copper water pipe. If there is a water meter in the water line, it must be bonded to ensure electrical continuity. The bonding jumper must be sized according to NEC Table 250.102 and must be connected to the water pipe on both sides of the meter. This bonding jumper provides a path for fault current to flow around the meter, preventing it from becoming energized during a fault. It's important to note that plastic water pipes cannot be used as grounding electrodes, as they do not provide a conductive path to the earth. If the water service is plastic, an alternative grounding electrode, such as a ground rod or ground plate, must be used. Ground rods must be at least 8 feet long and must be driven into the earth until at least 8 feet of the rod is in contact with the soil. Ground plates must have a surface area of at least 2 square feet and must be buried at least 30 inches below the surface of the earth. UFA grounds, also known as concrete encased electrodes, are another type of grounding electrode that can be used. A UFA ground consists of at least 20 feet of bare copper conductor encased in concrete. The concrete must be in direct contact with the earth. UFA grounds are typically installed in the footings or foundations of buildings. The resistance of the grounding electrode system must be low enough to ensure that overcurrent protection devices will trip quickly in the event of a fault. The NEC requires that the resistance to ground not exceed 25 ohms. If the resistance exceeds 25 ohms, the grounding electrode system must be improved by adding additional grounding electrodes or by taking other measures to reduce the resistance. Grounding and bonding are essential for electrical safety, and it's important to follow all applicable codes and standards when installing a grounding system. Consulting with a qualified electrician is always recommended to ensure that the grounding system is properly designed and installed. Proper grounding and bonding help to prevent electrical shock, fire hazards, and damage to electrical equipment. Understanding the principles of grounding and bonding is essential for anyone working with electrical systems. Always ensure that all electrical work is performed by a qualified electrician and that all applicable codes and standards are followed. Maintaining a safe and reliable electrical system requires ongoing attention to detail and a commitment to following best practices. Remember to regularly inspect the grounding system to ensure that all connections are secure and that there are no signs of corrosion or damage. By taking these steps, you can help to ensure the safety and reliability of your electrical system. The grounding electrode conductor must be connected to the grounding electrode in a manner that ensures a permanent and effective ground path. Approved methods include exothermic welding, listed pressure connectors, listed clamps, or other listed means. The connection must be accessible unless it is buried or concrete encased. The grounding electrode system should be tested periodically to verify its effectiveness. A ground resistance tester can be used to measure the resistance of the grounding electrode system to earth. If the resistance is too high, additional grounding electrodes may be required. In addition to grounding, bonding is also an important aspect of electrical safety. Bonding is the process of connecting together all metal parts that are likely to become energized during a fault. This includes metal enclosures, metal conduits, metal piping, and other metal parts. The purpose of bonding is to create a low impedance path for fault current to flow back to the source, which allows overcurrent protection devices to quickly trip and energize the circuit. Bonding jumpers are used to connect together the various metal parts. Bonding jumpers must be sized according to NEC Table 250.102 and must be connected to the metal parts using approved fittings. The green equipment grounding conductor that runs with the circuit conductors is used to bond metal enclosures and other metal parts. This conductor provides a low impedance path for fault current to flow back to the source. It is important to maintain continuity of the equipment grounding conductor throughout the electrical system. When working with electrical systems, always follow safe work practices. Wear appropriate personal protective equipment such as safety glasses and gloves. To energize circuits before working on them and use lockout-tagout procedures to prevent accidental re-energization. Test circuits to verify that they're energized before working on them. Never work on live electrical circuits unless you are qualified to do so and have appropriate safety precautions in place. Electrical safety is everyone's responsibility. By following safe work practices and adhering to applicable codes and standards, you can help to prevent electrical accidents and ensure the safety of yourself and others. Remember to consult with a qualified electrician if you have any questions or concerns about electrical safety. Electricity is a powerful force, and it must be treated with respect. By understanding the principles of grounding and bonding and following safe work practices, you can help to ensure a safe and reliable electrical system. The NEC is updated every 3 years, so it's important to stay current with the latest requirements. Changes to the code can affect grounding and bonding requirements, so it's important to be aware of these changes. Continuing education courses and industry publications can help you stay up to date with the latest electrical codes and standards. Investing in your electrical knowledge and skills is essential for maintaining a safe and reliable electrical system. By staying informed and following best practices, you can help to prevent electrical accidents and ensure the safety of yourself and others. The grounding electrode system is a critical component of the electrical system, and it must be properly designed and installed to ensure electrical safety. By understanding the requirements for grounding electrodes, including copper water pipes, and following applicable codes and standards, you can help to create a safe and reliable electrical system. Proper grounding and bonding are essential for protecting people and property from electrical hazards. Always prioritize electrical safety and consult with a qualified electrician if you have any questions or concerns. The NEC provides specific requirements for the type and size of grounding electrodes. The grounding electrode conductor must be connected to the grounding electrode in a manner that ensures a permanent and effective ground path. Regular inspection and testing of the grounding electrode system are essential to ensure its continued effectiveness. In addition to the grounding electrode system, the bonding of metal parts is also crucial for electrical safety. Bonding creates a low impedance path for fault current to flow back to the source, which allows overcurrent protection devices to quickly trip and de-energize the circuit. Bonding jumpers must be sized according to the NEC and must be connected to the metal parts using approved fittings. Maintaining continuity of the equipment grounding conductor throughout the electrical system is essential for proper bonding. When working with electrical systems, always follow safe work practices and adhere to applicable codes and standards. Electrical safety is everyone's responsibility. By understanding the principles of grounding and bonding and following safe work practices, you can help to prevent electrical accidents and ensure the safety of yourself and others.